instances are servers basically that forward traffic to multiple servers. Now until now we had EC2 instances which had the web services running, right? Now that was a manual task, right? If one web server went down, you went inside the EC2 and spin up a new instance, and we had the user data, and then it will take some time, right, to instantiate the instance, and then the web services could run, and then there is basically a downtime while you are doing that, and that task was manual, right? Yeah. So we don't want that basically, right? So what we do, so if you see here, we have a load balancer which is called ELB, Elastic Load Balancer, and then on the back of it you are running EC2 instances, say 3 of it, and which is running the same application. Okay, and next what we do, we basically don't want the people to directly access the instance like yesterday we had a public IP, we just directly accessed it on port 80 from the outside world, and then we were able to see the web services, right? But that was directly on the instance. Now what we will do is we will basically place this ELB, which is the term that AWS calls Elastic Load Balancer, but you will have multiple third-party vendors also producing load balancers, which are also called application load balancers. Some of the vendors I can remember out of my head is F5 LTM, if you have heard about it. F5 local traffic manager. So that is also a load balancer. But the AWS itself, they also provide this service, which is called Elastic Load Balancer. Now what happens here is you expose your Elastic Load Balancer's DNS to the outer world, and basically the user will hit on the DNS of the Elastic Load Balancer, and then Load Balancer is smart enough and intelligent enough to have the capability, and it knows about the instances which we will actually define. So it knows about the instances and what all traffic services they are running, and then it can do intelligent load balancing decision, and then forward the traffic to the member in that load balancer group. Right. So in this case, you can see the user came to the ELB, and the ELB forwarded to one of the instances, and the second came and it was forwarded to the other instance, and then third user came and it was basically forwarded to third instance. Now this basically is an algorithm which you can control. Now this case was like the round robin, which means you will go a top down, or in a sequence you will forward the request to particular servers, right? Now you can control that, but now you can see with this method that we have a kind of high availability as well, right? So our application is always online. Even if any EC2 instance failure is there, the Elastic Load Balancer is smart enough to know that that EC2 instance is down, and I don't need to forward. I basically don't have to forward the traffic to that EC2 instance in my background, right? So whatever EC2 instance is up and running, all the requests will be forwarded to those EC2 instances in the back of the load balancer. Clear? Why should we use a load balancer? Okay, so you just got an idea. Let's look what else we can learn. Now, spread load across multiple downstream instances. As I said, we have 3 instances, and we can spread the load on those instances. Expose a single point of access DNS to your application. As I said, we will expose the load balancer DNS to the public to access the application. Seamlessly handles failures of downstream instances. So the users are basically not aware of what's going on behind the scene with the EC2 instances. If it's, they don't know if it's down, or they don't see anything. They don't have that visibility. For them, the application is working fine. And the application, the ELB basically does regular health checks to your instance. We will see how it does that. Provide SSL termination. I mean, that is the most important part of using a load balancer. It works like a proxy. So it also gives you a benefit that you don't need to install multiple SSL certificates on your EC2 instance. Rather, you can just use one SSL certificate and attach it to your ELB, and it can do the termination as well. Decryption, encryption, which will be handled by ELB. So from that point also, it's a benefit. And there are multiple ways where you can enforce stickiness with cookies. We will see this in the labs. High availability across zones. Yeah, that is also a good reason why you should use load balancers, because now you can do what? You can just scatter your EC2 instances over multiple availability zones, over multiple data centers, right? So your EC2 instances that are behind the elastic load balancer can be between, inside a single AZ, or they can just go multi-AZ. So, okay, and separate public traffic from private traffic. That is one more thing that I will talk about. So why use an elastic load balancer? An elastic load balancer is a managed load balancer. Now, this is a managed service from the AWS. So you will not be actually in control of the instance itself, but yeah, you will be in control of how to handle the traffic on the ELB, right? An instance, an elastic load balancer is managed, a load balancer that is managed by AWS. AWS guarantees that it will be working. As I said, AWS takes care of upgrade, maintenance, and high availability, right? As I said, so when you are deploying an elastic load balancer, you will see an option on deploying this on multiple AZs. You just need to check box, and that's it. You are multi-AZ in just a few clicks. Okay. AWS provides only a few configuration knobs. As I said, this is managed by AWS, but you can do some tweaking, right? As we spoke about it, we do have the option to control the type of load balancing we want to do, whether it's a weighted or it's a cookie based or it's a round robin. So we have that option here. It costs less to set up your own load balancer, but it will be a lot more effort on your end. So yeah, so as you saw yesterday, you do have third-party AMIs available in the AWS marketplace. Like that, also you will have the say F5 load balancer, which you can deploy on your in your design. But working with those type of load balancer in the AWS scenario would be more complex design-wise, right? But using elastic load balancer, it will be more smooth and less cumbersome for you. And basically, it is integrated with many AWS offerings and services like the EC2. And one of the most important is the EC2 auto scaling groups. It's an amazing thing. Once you see it, you will, obviously love it. And then you have the Amazon ECS, which is the serverless services from AWS. It's an amazing offer, and also this is integrated with the ELBs. And also you have AWS Certificate Manager or CloudWatch. Now, AWS Certificate Manager is something where you can manage your certificates. You can upload your own certificates, or you can generate certificates from AWS. And also you have the CloudWatch, which is another service, which is basically a monitoring service. We will see in the future classes, right? Now, there are many more services which we will be talking in the future. Now, one of them is Route 53, which is basically the DNS service from AWS. Then you have the WAF, which is the Web Application Firewall. Then you have the Global Accelerator, which is the CDN. Now, I spoke about the health checks, which the ELB does on the EC2 instances that you attach an ELB to. Now, how does that happen, right? You basically create an ELB and also some EC2 instance, say one as of now, and the ELB basically does a health check. Now, this this is a traffic, right? This should be allowed on the EC2 instance, but this is done by default. So if you check, health checks are crucial for load balancer, because based on the status of your EC2 instance, the load balancer is going to decide whether I am going to forward the traffic to this member of the group. Right? You can say this is we have a group of EC2 instances, and say in AWS terminology we call as TG, target group, and also in many other load balancers terminology we call it as maybe group or TG or target group. So inside the target group you will be assigning nodes, which are basically your EC2 instances, right? So now the load balancer will be checking these nodes or the EC2 instances for health checks, right? Once it is okay, then only it will forward the traffic to those EC2 instances. The health checks basically enable the load balancer to know if instances it forwards traffic to are available to reply to requests. The health check is done on a port and a route /health is common. So we will see what route is, and the port that it does it on is HTTP, and port is 4567. Okay, now when you do a HTTP request, when the ELB actually does an HTTP request, if the response is not 200, which is basically called okay, if I get a response from a server, HTTP response saying 200 means it's okay, I can reply back to you, then the instance is unhealthy. If that response is not okay, then the ELB will presume that the instance is unhealthy. So that is how the ELB is going to frequently. Now the frequency is also is under your control, how frequently you want to check your EC2 instance so that the failover is much faster, right? Okay, the types of load balancers inside AWS. Now we are going to speak about the type and the difference between them. As I said, AWS has 4 kinds of load balancers. The first one is called the CLB, or classic load balancer, which is basically a version 1, and basically the AWS is not recommending to use this. This is an old generation, but this may come in your if you are planning to go for certifications, it is good to know that these also exist till now. It was basically launched in 2009, CLB. Now it does HTTP, HTTPS, TCP, SSL kind of load balancing. It's not basically an application load balancer, but yeah, it works on those protocols. Now the second is application load balancer, which is the new generation, was launched in 2016. You can just call it as ALB. So now if I say CLB, you just need to know that it's classic load balancer, and ALB is application load balancer. Now this works on the application level, like the HTTP, HTTPS, and the WebSocket. And then the third one is basically the network load balancer. This is again a newer generation, and this works basically on the network level, like on the layer 3 of the TCP/IP model. It can talk to the a layer on and can understand the IP addresses and all. Now this can also work on the TCP, TLS, and UDP level. So from the layer 3 upwards, it can understand every traffic. Now then again, there is a new offering, which is called the GWLB, Gateway Load Balancer. It is basically out of scope of this AWS Architect Associate, but yeah, you should know that there is one more load balancer called the GWLB. Again, this does operate like the network load balancer on the network layer. Overall, it is recommended to use the newer generations load balancer as they provide more features. So you would be mostly using ALB and the NLB. Okay? But in the demo, we will be only looking at the ALB. One of the reasons is NLB is not a free service. So if you want to use this, then you will have to pay some amount. But I will show you how to deploy these, and we can just see a demo of the application load balancer, and I can show you the rest of the load balancers. Some load balancers can be set up as internal, private, or external public ELBs. So now You can use the ELBs inside your design, working as a private load balancer, and you can expose them on the public as well. That's the first example that I gave, right? You can expose your ELBs DNS to the outer public users. The load balancer security groups, right? How it works. So let's try to understand this. Now you have a user, you have a load balancer, you have an EC2 instance behind the load balancer. The user basically comes on HTTP and HTTPS from anywhere on the public network. Now what happens? So you can see what type of rules you need on the security group, which is attached to your load balancer, right? You can see I need to allow 80 and 443, right? So that is the prerequisite. If I blocked 80 on the load balancer, it will be dropped there itself. It will not be coming towards the EC2. Now let's see. Now when I go to the EC2 after my load balancer basically allows, the security group is allowing. Now let's see the security group on my load balancer. EC2. So here you can see what I'm doing now. Now I'm calling the security group inside my security group of the EC2. As you can see, now I have the type HTTP, protocol is TCP, port is 80, but look at the security group. This is the security group of my, basically the load balancer, right? So that is how we control the traffic to the EC2. Okay, now good to know. Load balancers can scale, but not instantaneously. Contact AWS for a warm-up. Now, you can do a scaling even though you have 3 AZs already selected. Now, if you want to go above it, you will have to contact to AWS for a warm-up. Troubleshooting. Now you can have these errors. So these are client-induced errors. And these are basically 5xx errors are basically from the application induced errors. So behind the ELB, if you have any applications, if you see these errors, that means it's nothing to do with the load balancer. It is because of the application. And if you find 503 error, means the target or the TG, or you can see the nodes, right? The EC2 instance are not registered, or maybe they are at capacity. If the load balancer can't connect to your application, check your security groups. Obviously, if you don't allow the security groups to access that particular port and application, obviously it will fail. Now you can do monitoring on this as well. ELB access logs will log all access requests, so you can debug per request, which is basically done when we will see the CloudWatch metrics. And this will give you an aggregated statistics like connection count, etc.